Uh, Hello, Year 7. I've made a couple of little videos for you guys so you can revise these things as we go through. We're just starting our mixtures unit now, but you'll need to do this as a test later. So let's have a look at our mixtures unit. Just first, we need to think about states of matter. So matter's all the stuff around us. I'll do a little video on the particle model too. So matter can exist in one of three states on our planet. There's a fourth state that tends to occur in the universe. So things are normally solid, liquid, or gas. And as you can see in this diagram, essentially the more energy you add in, so you've got more add energy, the particles can move further and further apart, and you go from solid to liquid to gas. And then, of course, if you take the energy out, you can go from gas to liquid to solid. So everything on the planet can be in one of those states, although it needs energy in or out to make that happen. And some things become different states much quicker than others. So, when you keep that in the back of our mind, solid, liquids, and gases. We also have things called pure substances. And so, a pure substance is simply a block of something that's one type of atom. So in this case, we've got gold ingots in our diagram here. And each of those gold ingots is essentially just gold atoms. There's probably a little bit of impurity, but essentially it's just a gold atom block. Gold doesn't stay like that in the real world. We have to make it do that by heating it to great temperature and burning everything else off. We also have things called compounds and mixtures. Now, we're not worried too much about compounds or pure substances at the moment, but just so you're aware that they exist. Compounds are formed when two or more substances join in a chemical reaction. Now, this means they're actually much harder to get apart again too. So if you get carbon and oxygen together and make carbon dioxide, to get the carbon dioxide to come apart to make carbon and oxygen again takes quite a bit of energy. We're going to play around with mixtures. So mixtures are a matter of two or more different substances. They could be pure substances, they could be compounds, they could be other mixtures, could be all those things joined together. And if we look at that lovely cake sitting there, making us all hungry, when we bake a cake, we make a mixture. It's a mixture of all sorts of other bits and pieces. So we're going to look at mixtures because mixtures are easier to get apart. And we'll do some separations in the next unit after mixtures. So there's some words you need to be aware of and need to learn. So there's some language here that you need to know. So first one is solvents, solutes, and solutions. And there's a lovely solution there in the image. I thought I'd keep you guys getting hungry. So here's a lovely hot chocolate. Got some marshmallow or something to put on top. So there's some hot chocolate. Essentially, the hot milk is what we call a solvent because it will dissolve the solute, the drinking chocolate. And we mix them together, we make a hot chocolate, and the hot chocolate we would call a solution. So solutions, a solvent and a solute joined together, or many solutes, not just the one solvent. And so you've got lovely hot chocolate. If I add some sugar to that, that'll be a second solute in the solvent. Then you need to know about suspensions. So a suspension is when we mix two things together, or more than two things. Again, you've got that one solvent that's dissolving the other things in it. So you might have a number of things dissolved in this solvent. The particles are suspended, they sort of hang in the solution, but after time they'll tend to sediment out, they'll fall to the bottom and form a solid on the bottom. So here you've got this lovely solution of suspended particles, and over time they've been sitting still and the suspended particles all fall to the bottom. I'm going to call that the sediment. What else we got? Colloids. So there's different types of suspensions. One's called a colloid, and the milk's actually an interesting example. It could be either colloid or emulsion, our next one, but it's a good example with one you're aware of. So colloid is a mixture in which the particles are small enough they stay suspended, so they don't fall to the bottom and clump up as a sediment. And of course you can still see them, we'll see their effect. So milk's essentially water with milk fats made by the cow suspended in it, and they remain in suspension, they don't fall out. So we can still see them, we'll see their effect. Obviously milk looks like white stuff, not clear water. And so milk's often used as an example of a colloid. It can also be an example of emulsion because the fats tend to clump together and float to the top. We don't see that much in milk anymore because we buy it with the milk fats removed, but natural milk straight from the cow will have some milk fats on top. So an emulsion is when you have small droplets of one liquid suspended in another liquid. And good old food analogy again, the vinaigrette which you might put on your salad is an emulsion you've made in the kitchen with some oil, maybe some balsamic vinegar. This one looks like it's got lemons in it. So you're making a little dressing for a salad, and it's a classic emulsion that you find all over the place. And then the other two big ideas are concentration and dilution. And they're the opposites of each other. So if I've got a substance, if I've got a solution, and I want to make it more concentrated, I'll put in more solute. So to make something more concentrated, increase the amount of solute, or decrease the amount of solvent. So I could boil off some water maybe. I like my coffee strong, so I put more coffee beans in than other people, and so I get a nice strong coffee. It's more concentrated than maybe Mrs. Chan likes it. To dilute is basically the opposite. So I want to dilute something, I increase the amount of solvent or decrease the amount of solute. So in this case, if you're making cordial, you get the cordial concentrate off the shelf in the supermarket, and then you add water. And some people like their cordial stronger than others, but however much water you put in, you're diluting the original cordial to a solution you like. So some people make it a bit too weak. So concentrating, making stronger, diluting, making weaker. So that's a quick summary of our mixtures unit. We're going to do lots of experiments and other stuff with it, of course. But this might help you when you prepare for the test. And that's done for now.